Let us assume that these are two busy roads. So these line segments here are showing two extremely busy roads. Now you want to open a shop. Where would you open this shop? If you open your shop on this road, then you would be left out by customers of the other road. So the customers on the other road, you'll miss out on those customers. Similarly, if you open your shop on this road, then you will miss out customers on this road. So where should you place your shop such that you get as many customers as possible? That should be the aim. So let us say the shop is somewhere in the center. Now where exactly is the question? So where do you think we should open the shop? Of course, the shop has to be opened at such a point such that it is equidistant from both these roads. If this would be equidistant from both these roads, that is, the distance of this shop from both the roads would be the same, then I can say that yes, customers from both the roads can come to the shop, and hence I maximize the number of customers that come to my shop. So this is my aim. We know that perpendicular bisector gives us points such that they are equidistant from 2 points. What do I want now? I want all such points that are equidistant from 2 lines and not points. So perpendicular bisector will surely not help me. Let us try to recall what angle bisector is. So what is an angle bisector? If AE is an angle bisector, that means that AE is actually bisecting this angle which is formed at A. So, bisecting the angle, that means if this total angle was 2x, then this is x degrees and this is also x degrees. If the total angle was 2x. So, the angle is being bisected by the line. That is what an angle bisector means. Apart from this, if you draw any point on the angle bisector, so this point say, or this point, let's call it F, G. So any point on this angle bisector would be equidistant from the two lines that are forming the angle. Equidistant, distance from a point to a line, remember, is always taken as perpendicular distance. So equidistant means the perpendicular distance is the same. So if I draw a perpendicular from this point to either of these roads, both the perpendiculars would be same in length. That is, it would be equidistant. Similarly, if you take any point, say G, on this angle bisector, then again, the perpendicular distance from a point to line is always taken as perpendicular distance. This perpendicular distance on both the sides would be the same. So if you take any point on angle bisector and you draw perpendicular from that point to the sides which is forming that angle, then that distance is the same. So this is exactly what I need. So for my shop, I can have these, if there were two roads, what I can do is, I can put the shop somewhere in the angle bisector. Now let us assume that there are three busy roads that are actually forming a triangle. Now where do I put this shop? Where do I buy a shop, or where do I open my shop? All I need is that the shop should be located at such a point such that it is equidistant from the three busy roads. From all these three roads, it should be equidistant. Why? Because that would attract as many customers as possible. That is what I need. So for that, what I'll do is, I'll start with two roads. Let's say these are the two roads, AB and AC, and I draw an angle bisector. Now this angle bisector guarantees me that any point on this angle bisector would have the same distance on both the line from both the roads. So distance from both the roads would be the same. That is the perpendicular distance. I want the distance of not just these two roads to be the same, but of the other two roads also to be the same. So what do? I draw another angle bisector. So let's say this is the angle B, which is being formed by AB, roads AB and BC. So with these two rows, I get another angle which is B, and I draw angle bisector such that it bisects this angle B. Now I see that this angle bisector meets the previous angle bisector at some point. Now this point is on this angle bisector, which is the pink one. If this lies on this pink angle bisector, then that means it should be equidistant from the lines which are forming this angle, which is BA and BC. So the distance, which is the perpendicular distance from this point to the sides BA and BC should be the same. Now, if you carefully observe, then this blue point also lies on this green angle bisector. Now, the green angle bisector is bisecting angle A, which is being formed by AB and AC. Hence, the distance from this line to this point to both these lines should be the same. So, this distance should also be equal to this distance, which is the perpendicular distance. So I get that this is a point which is equidistant from all the three sides. Now, what if I draw another angle bisector? I have another angle C. Now, what if I draw another angle bisector? Would this angle bisector actually intersect at this point? Let us see. Let us draw another angle bisector. So I draw another angle bisector. What do I observe? That all these three angle bisectors intersect at a point. And this point is called as in center. The point where angle bisectors intersect is the point which is called as in center. Now, let's look at this point. So this is the point which is the in center, and hence this is a point where I can open the shop. This is a point where I can open the shop, because this point is equidistant from all the three sides. So the perpendicular distance is the same from this point to any side. The perpendicular distance is same, and hence I can say that this is an in center. Now, why in center? Is this a center of a triangle? Is it inside the triangle? That's why it's in center. Why is it in center? So let us see. If you take D as your center and either of these lines as the radius, and try drawing a circle. So if you do that, you can basically get a circle which just touches the sides of the triangle. So this circle is inside the triangle, and hence it is called in circle. Now this point, which is the point of intersection of the angle bisectors, was called in center. Now why in center? Because it is the center of in circle. So it is called in center. That's why this point is in center, and this circle that is formed is called in circle. For any triangle, you can draw a circle which would just touch the sides of the triangle inside that triangle. And this circle is the largest circle that you can draw inside this triangle. If I try to move this circle a bit, if I increase the radius, make a larger circle, then that circle would go outside the triangle. So this is the largest circle that can fit inside this triangle. And how do I draw this largest circle? To draw a circle, I need the center and radius. Center, easily you can find it. Find the angle bisectors of all the three angles. The point where the angle bisectors would meet would give me the in center. With this in center, take the perpendicular distance to either of the sides as the radius, and with this center and radius, you can draw this in circle. Also, in center always remains inside the triangle. For an acute also, for a right triangle also, and for an obtuse triangle also. The in center always remains inside the triangle. And with this in center, we can also make an in circle. Now the triangle can be of any size. You can always make a circle inside a triangle. And this circle is called the in circle. So this is what we've seen, that angle bisectors of the three angles gives me a point which is the in center. With this in center, you can actually make a in circle which would just touch the sides of the triangle, and this in circle is actually the largest circle that you can draw inside a triangle.